Good. Okay, so the first day of the class for the chemistry, we will go over the basic knowledge of the chemicals, and then next week Tuesday we'll talk about biochemistry. So let's talk about chemicals. So here is what we're going to talk. You can read all these things on the slides, but let's make it a little bit easy for you to understand. So let's give an example of C carbon 612. And this is 6 is a neutral number. And that 12 is a mass number. Okay, so because carbon is the basic of everything, so we come from there. Now what this really means, we can write is talk about an atom. The atom is like non-charged. And it should be composed by nuclear and electron cloud. So inside you will see, let's use the carbon as an example, is you have 6 proton, which is positive charge. Then you have 6 neutron, which is non-charged. And this composed by is nucleus. And then outside, right here, you have these are electron. And because electron is surrounded, so we also call this is electron clouds, like clouds in the air. Okay? And every time the proton and the electron, they should be the same number. And because electron is too light, so we do not really take consideration for it into the mass amount or mass number of a carbon. Okay, so that's why this mass number is always a number of proton add the number of neutron. Okay, so that is what we have to explain using a carbon to what we see on this slide. So we can read them again. The atoms is a basic unit of a matter. There's 3 components: neutral, proton, electron, and which means neutron uncharged, proton positively charged, electron negatively charged. And then proton and neutron, we call it a nucleus, and they're surrounded by electron, which is like a crown, so we say it's an electron crown. Okay, now this is already mentioned. An atom is you have an atom number. That is number of protons in the nucleus. And the atom mass, which is molecular weight, so we say it's a mass weight. That is the sum of proton and the neutron. And because electron is too light, so we do not take consideration of that. Okay, now this table right here, we will talk a little bit more. So this is gives hydrogen, carbon, nitrogen sulfide, phosphate sulfide, the symbol, so atom number, mass number, number of covalent bonds, and approximately amount in the cells. Okay, so let's talk about that. So you need to know that every single live matter, which is basically composed by hydrogen, or living system composed by hydrogen, carbon, oxygen, and nitrogen. Those are the 4 major components. It is almost add together around 99%. Then sulfide and the phosphate play another important role in the life cycle. Okay, so that's why you see the amount. That's add together 0.5 is almost 99%. So atoms of an element can have different mass numbers. This is something you know that This is carbon 6. So carbon 612 in the real life, it is about 99%. However, we do see sometimes, especially in the bacteria or some synthesized chemicals, we see this. Maybe 7, maybe even 8 that comes out. Okay, what are these? Which means you have the same proton numbers but different neutron numbers. Those are called isotopes. And isotopes usually used to have a lot of things happens in the biology area. And this is, if we expand a little bit, when we talk about iodine 125, these are usually, we talk about this radiation. Okay, used as a radiation activities. That's called isotopes. Now, this is I already talked about. The electron right here. Okay. Now we talk a little bit more about this electron. So we have a nucleus here. You have an electron there, which is surrounded like a clouds. Now what happened is, it's not really that easy. Usually they accumulated, which is first is a layer close to the nucleus. So like that. And this first layer usually 2 electrons. But how about outside? They can accumulate it more and more. But when they reach the optimal level, or we say it's a saturated or status, saturated status, this is usually reached to 8 electrons. Okay, so we have a terminology called octet. That means 8 electrons to reach saturated status. S-T-A-T-U-S. Okay, now usually what happens with more electron adding into the outer layer of the nucleus, the further, the more energy. The further, the more energy. Okay, that's what they really happens. Now, here we already talk about that. This is the one I gave you example at the beginning, and the first shell hold up 2. Subsequently, they can hold up to 8, and that is called octet rule, because more stable, more saturated status. Now here comes another thing, which is called valence electrons. To give you an example, still use carbon. The valence electron, that is important. This is called the Lewis structure. Why it is important? Because of the valence electron will let a chemical can be communicated with other chemicals. Then they can finally become a compound. Because of these valence electrons, they will form chemical bond. That is what we're going to talk next. Okay? So, all these electrons outside, okay, some of them become valence electrons. They will be to either for the atom you can gain, you lose, or you exchange, or you share, because they want to communicate with other chemicals. Therefore, they can form 3 major bonds, which is covalent bonds, ionic bonds, and hydrogen bonds. So these we can talk a little bit more. So we say valence electron will form the bond. The bond which is encoding 3. So we talk about these one by one. Ionic bonds, covalent bonds, and the hydrogen bonds. Okay, ionic bonds. First of all, it's a very simple example is sodium chloride. Sodium chloride. Chloride donate 7 electrons, and sodium contributes 1 electron. And they could be attacking with each other. That is the example for ionic bonds. And this positively charged right there is called cation. And it's negative charged is called anions. So they combine together is not charged. This is the one. Usually we say it's a relatively weak bond. Now, why we call it? Sodium chloride can be dissolved in the water, but sodium and chloride, they will not be separated. But they are under certain conditions they can separate, which is if you using electricity for the water. This is something I will mention in detail when we talk about the water. If you have a food grade sodium chloride, okay? Sodium chloride with water, then you using electricity, it will be split, become what is this? Sodium hydroxide. What is this? Hypochloric acid. This is a major component for antibacterial in chlorine. Therefore, this is very simple reaction. Generate electrolyzed water. That is where they come from. And in European countries, they want to replace chlorine with this reaction because they think it will not accumulate chlorine off gas and chloramine as a chlorine byproducts during the food processing. So since we're talking about the food chemistry, that's why I explained a little bit. But this example tells you this is a relatively weak bond because sodium chloride underneath electricity or any of the electricity equipment that can be separated. And this we call it antimicrobials. It's antimicrobial. And this is like a sanitizer. Okay? So that gives you an example. So ionic bonds, they form because of attraction between negative and positive charge. A good example is sodium chloride. Now covalent bonds. Covalent bonds, first of all, this is a relatively strong bond. Not easy to break down. This is the first thing you need to know. So give you a very easy example. Sugar, glucose in the body, it's not easy to break down. You need a high temperature, you need enzyme, or other things to help. Because the covalent bond there is relatively strong. That is what we explained right here. Okay, now what is the covalent bonds? A good example is we have carbon and we share with 4 hydrogen atoms. This is a method. Okay, that's an example for covalent bonds. Now, the covalent bonds is relatively strong, so therefore we coming out another concept that's very easy, called organic and inorganic. Now, what means organic? Which means chemical composed by any type of the connection between hydrogen and carbon. Inorganic is others. I tell you one thing, when I teach general microbiology, I said one means fermentation, which means electron donor is an organic chemical, electron acceptor is also organic chemical. What that means, one means organic chemical, which means it's containing HCl bond Z, which means they have that component Z. Inorganic, which means others. Because the definition of respiration is electron donor is an organic chemical, and the electron acceptor is an inorganic chemical. Okay, so that's something I want to mention here. So you can see when pair of the shared electron will covalent bonds, the carbon bonds with the hydrogen to form organic molecules, and the others we call it inorganic. And a good example here is methane. And it's difficult to break down because it's relatively strong. Okay, now here comes another thing. We mentioned the hydrogen bonds, we haven't mentioned that. Is that right? Where they come from? This is actually comes from covalent bonds. Because covalent bonds have one characteristics, which is called polar system. So here's something. You know the electron could be donate or accept or like sharing. So if it's non-polar, which means they equal share electron. If it's polar, it's non-equal share electron. Okay. This is very important. But because of this, comes out hydrogen bonds. Now, why they will have this non-polar or polar electron accept ability? It depends different type of the chemicals. So if you only have C and H, this will be non-polar. But if the chemical compounds have N or O, this will become polar. Okay? Because the reason is N larger than O, larger than C, larger than H, regarding talking about electronegativity, which is ability, negativity, T-I-V-I-T-Y, ability to attract electron. Okay, so here you can see the value. Oxygen should be the first one. Oxygen is higher than nitrogen, higher than carbon and hydrogen. This tells you every different type of chemical, their relatively electronegativity is different. Oxygen stronger than nitrogen, stronger than carbon, stronger than hydrogen. Because of that, so it's not going to be equally shared because they can more easily to attract or accept electron. Okay, others are a little bit difficult. Therefore, it's become a polar system. Now, because of this polar system, therefore, the results have a hydrogen bond. Now, a good example for hydrogen bond is water. And you can see right here, for the water, you're using this color spectrum. This is actually the color spectrometer. They measure the electron density. You can see surrounded oxygen, that electron density is very high, and oxygen is lower, because here you can attach another molecule of the water. Okay, so that's a covalent bonds. And they introduce hydrogen bonds. Now, this is the hydrogen bonds. When you see the hydrogen bonds like that, it's very easy to let you understand it. Seems like something we see, like a double bands of the DNA. The A and T and G and C, they connect together with the hydrogen bonds. And the hydrogen bonds usually is a polar molecules that attract each other. The number could be lower, could be higher, it really depends. It's a molecular to molecular recognition, and it is relatively weak. Or we can say it's very weak. I will say this bond is very weak. Okay, this bond is very weak. Now here is one concept I wanted to talk about. Is called Velcro analogy. So one is Velcro analogy. This is something is easy, but you probably not recognize it. That's called Velcro. What this means? Which means based on the number of the hydrogen bonds, the hydrogen bonds could become strong in certain circumstance or certain scenario. So I give you an example. We have another slide. Water can move freely at room temperature. This is everybody knows. You put one bottle of the water, they can move. Because of the water they connected with hydrogen bonds is very weak. But how about ice? Ice, you cannot move it because ice is one molecule of water attract each other, which form molecule of the water, then become a rigid crystal status. And this is called Velcro analogy. Then the ice makes very strong. It cannot move at all. Okay, so that's an example. Another Velcro example is the DNA and RNA. A DNA double layer when they combine together. And this is actually talking about, we call it some hook and loop, hook and loop status. That's for the DNA structure. Okay, so that's what we mentioned about here. Okay, morality. This is easy. This one is relatively easy. Is we go back to talk about basic chemistry, very basic chemistry. Okay, let's say I want to dissolve. This happens in the lab all the time. Some people don't know, even they study for PhD or master, they don't know. I want to dissolve one more sodium chloride, or let's say in water. What we should do? So how we do it? You're gonna wait. How many grams? What is the mass number of sodium? 23. What is the mass number of chloride? 35.5. You add them together. 58.5. So how to do it? How to make one more? You wait 58.5 gram sodium chloride and dissolved in 1 liter water. Okay? That is, you make one more. Now what means one more? This means 6.02 multiplied by 10 to the 28 particles. We have a terminology for that, if you still remember. Avogadro constant. Is that called Avogadro constant? Now be careful, when we talk about mole, we always talk about is chemical ingredients. There's a joke when we learned in the high school. When you go to buy a rice, you're never going to tell them, I'm going to buy one more rice. We only say kilograms or grams or pounds, is that right? Because that's used to measure substance. But when we talk about the molecular level or chemistry level, we talk about mole. Okay, so that's something like a joke, and just let you remember. It's only referred to some molecular stuff. So this is easy, okay? Now, in the chemistry class, the mass number of sodium chloride, potassium chloride, usually you can have a table, you can find it, okay? That's just your review. Okay, this is I already mentioned, water. Water is making 70% of the live organisms by weight. It's a polar molecule, which means the electron is not equally shared. And the oxygen has more ability to attract electron because its electron negativity is higher than oxygen, okay? Liquid hydrogen bonds continually form and break. That's why the water can move freely at room temperature. Ice, when water molecule forms 400 bonds with another 4 water molecules, therefore it's more crystal status. And we will learn later on the crystal status is not good. So let's say you buy a beef, you have a beef, you frozen it at minus 20 degrees Celsius, not that lower, maybe minus 5. And then you frozen about 6 months, you take it out, then you cook, it's not going to be good because the crystal will be damaged the tissue. So what we should do, we don't want those really low temperature, long time freezing. That's why they generate a fast flashing freezing. So let the temperature drop quickly because they do not want it to go to crystal status, they want to go to a nuclear status. The detail we'll talk about in the water section. Okay, so that just give you an idea. Okay, now water is a very good solvent. Can dissolve lots of the chemical can dissolve into water because of its polar nature. Because of the polar nature of the water, therefore we comes out to very simple, but people always mess it up with both of them. That is called their reaction, whether they like water or not. So some compounds, if they like water, hydrophilic, I just say they like water. Okay, how about if they dislike water? Hydrophobic. I'm not saying water hates, just say dislike water. It's really easy. So what is hydrophilic? Sodium chloride. What is hydrophobic? Oil, is that right? It's not going to dissolve in the water. How do you understand this sentence? Water with dissolved substance freezing at lower temperature.